Hello everyone, I'm Bee. Today we're going to learn about algorithms and how to design simple ones. So let's dive in and learn more. So what exactly is an algorithm? An algorithm is a set of step-by-step instructions to solve a problem. Think of it as a recipe with steps that guide the computer through solving a problem. Just like a recipe helps you make a delicious dish, an algorithm helps a computer solve a task or complete a task. Algorithms can be found in many areas of study, including mathematics, computer science, and even everyday life, like the cooking example. Let's create an algorithm for making a peanut butter and jelly sandwich. First, we get 2 slices of bread. Next, we spread peanut butter on one slice, then spread jelly on the other slice. When that's done, we can put the 2 slices together. The only step left to do now is to enjoy the delicious sandwich. As you may have noticed with our peanut butter and jelly sandwich algorithm, a successful algorithm has certain characteristics. An algorithm must have clear instructions. Each step must be precise, specific, and to the point. Saying, "get some bread," might be misinterpreted. Saying, "get 2 slices of bread," is very specific about the number of slices, so there is no confusion. The algorithm must have a finite number of steps, meaning that it has an end. If all we said was spread peanut butter, you would just start spreading it all over everything everywhere and never know when to stop. By saying to spread it on one slice of bread, you know exactly when that step is done. Algorithms must have well-defined inputs and outputs. It should take specific inputs and produce desired outputs. Inputs are the items you put into the algorithm. In this case, it is bread, peanut butter, and jelly. Outputs are the item or items you get when the algorithm is finished. In this case, it is a peanut butter and jelly sandwich. The algorithm must be deterministic, which means that the same inputs will always produce the same outputs. Putting our ingredients together while correctly following the algorithm will always produce a peanut butter and jelly sandwich. Every time you follow the recipe, you get the same output, a peanut butter and jelly sandwich. And lastly, our algorithm must be feasible. This means that the algorithm must be practical and possible to execute. Since our peanut butter and jelly sandwich didn't include any time travel, teleportation, or anything that cannot be done at the present moment, I'd say making it was feasible. Now that we understand what an algorithm is, let's learn how to design a simple one that we could program a computer to use. We will be designing an algorithm for finding the largest number from a list of integers. Let's say we have a list of numbers, and we want to find the largest number in that list. Here we have 7, 12, 5, 16, 3. Start with the first number in the list and call it the largest number. From left to right, 7 is our first number, so we call this our current largest number, because we haven't looked at any other numbers yet. Compare the largest number with the next number in the list. The next number is 12. Is 12 greater than 7? Yes, so this number replaces 7 as our new largest number. Now we will continue to compare each number in the list to the current largest number. 5 is our next number. Is 5 greater than 12? No. On to the next number. Is 16 greater than 12? Yes, so what do we do? Right, we replace the current largest number, 12, with the new largest number, 16. Is 3 larger than 16? No. Now we've finished our list, so our largest number is 16. Let's review the steps we completed now that we understand the algorithm. Start with the first number in the list and call it the largest number. Compare the largest number with the next number in the list. If the next number is larger, update the largest number. Repeat steps 2 and 3 for each number in the list. After the last number is checked, the current largest number is the answer. When you first looked at the list of numbers, it was easy to see that 16 was the largest number on the list. Why then did we need to use an algorithm to solve it? Well, the great thing about this algorithm is that it can be used on a small list of numbers and also a very large list of numbers. As a human, we don't mind looking through a set of 5 numbers to search for the largest. But if we had a set of 1 million numbers, well, that's a job for a computer. You see, computers don't care how many times they have to go through the algorithm. As long as they have a set of steps that they can follow, they will get the answer. Often very quickly, too. So designing an algorithm that works for a small set of numbers and then letting a computer apply it to a larger set is one of the ways algorithms can help people solve problems faster. Let's recap what we've learned about algorithms. An algorithm is a set of instructions that helps solve a problem. It consists of clear steps and has well-defined inputs and outputs. We can design simple algorithms to solve various problems. Algorithms are used in many fields, including computer science and everyday life. Remember, algorithms are like recipes for computers, so keep exploring and designing your own algorithms, and you'll be able to solve problems quickly and efficiently. Be sure to complete the practice questions and extension activities before moving on to the next lesson. Remember, in the universe of coding, the possibilities are infinite. Hey, hey.